Good morning, everyone. In this session, we- we'll discuss about the continuation of the last class, that is regression. In the last class, we started about what is introduction to regression analysis, what is regression, and what are the types of regression. Now, in this session, let us discuss about residual. So, what is this residual in regression? When we perform regression, I already told you, it is we are going to draw a line that is best fits the data. So when you perform regression, we get a line of best fit. You can see this. This is a line of best fit. So a residual is the vertical distance between this data point and the regression. Here is a data point. The distance, the vertical distance from this data point to this one is called as the residual. Each data point has one residual. When you see this regression line, above the data points are called as the positive residuals. Whatever the data points above the regression line are called the positives, and the data points below the regression line are called as the negative residuals. And if the line passes through the data points, the line passes through these points. If the points is passing through this regression line, then we can say that residual. So what do you mean by these residuals? Residuals are nothing but sometimes these are also called as the errors. It means there is some unexplained difference that an error isn't not explained by the regression line. The residual is also expressed with an equation and it is represented by a symbol E. It is nothing but that it's a difference between the predicted value and the observed value. The predicted value is something represented by like this, y cap. So residual is equal to observed value minus predicted value. That means in one more way also we can say that it is nothing but the actual value minus predicted value. So this is what we call it as the residual, or in this way we are going to find out the errors in regression analysis. So let me explain this, how we are going to find out all these things. This is one representation of a regression. You can see here, these are the data points. This is the line of best fit. And in x-axis and y-axis, we are going to have quantitative variables, that is continuous variables, where we have this is independent variables and this is dependent variables. So this regression line predicts the changes, that is maybe increase or decrease in y when x increases by 1 unit. That is, whenever an independent variable increases by 1 unit, there will be a change in y. That change may be increase in the value of y or maybe decrease in the value of y. Now, let us analyze one problem. There are some students there. To take some student data, their study x-axis is study time hours. So, and their GPA. Yes, this your GPA depends on how many hours you study per week. So, if you study well, and obviously your GPA will increase. This is what the representation. So, this is the best line of regression. If you are not studying and if you have spent time on Facebook, then gradually your GPA will come down. This is the negative representation. This is not the best fit line. We can't say it is decreasing. Whereas you see in this one, it is increasing. Here it is decreasing. So how much you spent on Facebook, that much GPA you are going to reduce. So a regression line is represented by an equation called as y equal to b naught plus b1 into x. It is similar like yesterday I discussed, that is y equal to mx plus c. It is a straight line equation. In mathematics, we know very well that it is a straight line equation. The same way, it is represented a linear equation. This linear regression is represented by something like this, that is y cap. This is predicted value of y. This is the intercept, this is the slope, and this is x, any value of x. It may be any independent variable. You can say it is a dependent variable, or that is we are going to predict the value of this based on this b naught plus b1 into x. Let us solve this one with the help of this same example. So here y will be this grade point average and x equal to study time. So if you study well, if you spend time on a study, yes, obviously there will be a positive relation. That's why we can say it is b naught plus b1 into x. Okay. So it is C. B naught is the intercept, B1 is the slope. And there will be, as it is increasing, so we are going to see it as plus. If it's the same example, if you time spent on Facebook, the GP is gradually decreased. So that's why our formula will become minus. Why? Because it is gradually decreasing. So in this way, we are going to calculate the y of y value. Now, how we are going to find out this y value? We have to know, we know already x value. We have to find out the y value, b naught and b1. Let us see how we are going to find out these values. So this y b naught plus b1 into x, this b naught is calculated by y bar minus b1 into x bar. So this y bar is nothing but the mean of x values. X bar is nothing but the mean of x values. And b1 is r sy divided by sx. That is standard deviation of y divided by standard deviation of x. R is the coefficient correlation. That is, you can give it as covariance of x comma y. This R is represented by covariance of x comma y. So now with one example, let us solve how we are going to find out the values of b naught, b1 and how we are going to calculate the predicted value. Now, suppose this is one example in this class we are going to discuss. That is, suppose a researcher wants to predict a student's GPA from the amount of time they study each week. So these are the list of students and this is the study time, and according to their study time, this is the GPA that particular student has achieved. So if a particular student George has studied 1 hour per week, he got 2.0 GPA. If he studied for 2 hours, he got 1.5. Similarly, 3, 5, 6, 10, he got 4.5 GPA. Now, let us plot this in a graph. Okay. So, now researcher wants to predict a student's GPA from the amount of study done. Now he wants to predict a student's GPA. So how we are going to predict a student's GPA is we have to find out the value of y. That is b naught plus b1 into x. This value we have to find out. So this is xi, number of hours they studied, and this is the GPA, and this is the number of hours they study. You can see this is the representation. Now xi, this is x and this is y. So how we are going to represent? For 1, it is 2. For 2, it is 1.5. Like this, we are going to plot the data points. You can see. As per this, we are going to plot the data points. See, this is 1, 2.0, 2, 1.5. Then 3, it is 2.5. Then for 5, it is 3.5. Like this, we are going to plot the data points. Now, we have to draw a line which best fits the data. So, we are going to draw a straight line, okay, that it is going to fit the data. That is what the concept behind this regression. Okay, see this one. Now, let us find out this this predicted. Now, we have to predict the GPA for a so and so hours a particular student has studied. Now, after this, we got the values as something like this. X bar equal to 5, Y bar equal to 3, Sx, 3 point, Sx, Sy and R. So, how we got this X bar? This X bar is, already told you, mean of the given value. So, when you see this table, when you calculate this mean, X bar is equal to sum all these things, we will get 35 divided by 7, we will get 5. And when we want to calculate Y bar, it is total, we will get it as 3. So you add this, you will get 21, 21 divided by 7, we will get it as 3. Now, similarly, S of x. So what is the formula for standard deviation? It is nothing but square root of sigma xi minus x bar whole square divided by n. So the value you you calculate and you You solve this problem, you will get it as answer as 0.3.023. Similarly, standard deviation of y, what is the formula? Sigma yi minus y bar whole square divided by n. So here we are going to get as value as something 1.08, or maybe some variation will be there. The answer what they have given here in decimal points, you may get some variation, or may he will get here you will get exactly 1. Let it be. Okay. Now we have to find out the value of r. The r is nothing but the coefficient correlation. R equal to, it is given by, we already learned in the last unit how we are going to find out the correlation is covariance of x comma y divided by standard deviation of x into standard deviation of y. This is the formula. So, what is this covariation of x comma y? What is the formula? It is sigma xi minus x bar into yi minus y bar divided by n. Here don't take n minus 1. Here we are saying for a data set, not for a sample data set. So we should not take it is n minus 1. We have to take by n. So now we will get r equal to 0.95. Okay. This is how we are going to find out all these values. To know the predicted value, we have to find out all these values. Okay. Now substitute all these values in the given formula. That is, we already know that y equal to b naught plus b1 into x, whereas b naught is given by y bar minus b1 into x bar. Okay. So substitute these values, and b1 equal to r into standard deviation of y divided by standard deviation of x. Remember these two formulas. Substitute all these values in this. We are going to get what is b naught and b1. Substitute these values, you will get b naught as 1.45, or if you calculate, maybe these values may be little bit vary will be there, 1.44, and b1 is, it will be some, when I calculated, I got it as 0.312. A little bit variation will be there after decimal points. Okay, let it be. Okay, this is how we are going to find out the b naught and b1 values. Okay. Now, so our equation will become like this. Our equation is y equal to b naught plus b1 into x. So substitute all these values. So b naught is this one, b1 is this one. Now, see, this is the representation. So this is the b naught value. Okay, intercept, and this is the slope v1 equal to 0.311. In this way, we are going to represent in a regression line. Now, this is called as the line of least square regression. If a question comes, find out the predicted value using the line of least square regression, this is the formula you have to use. Okay, y cap equal to b naught plus b1 into x. Now, the slope of a regression line predicts the change in y when x increases by 1 unit. Whenever there is change in a unit of this x, yes, obviously there will be a change in y. Now, a question. As study time increases by 1 unit, we predict a student's GPA to increase by 0.311x. Yes, of course. Why? Because this is the value we got. Now, the question, we have calculated all this. Now, the question is, if a student is studying for 6.5 hours a week, then what would be his GPA? The prediction. You have to predict what would be his GPA if he studies for 6.5 hours. Not only 6.5 hours. If you give 10 hours, 12 hours also, you can easily say. Why? Because we have calculated the value of B naught and B1. Once you know the B naught and B1 values, you can easily predict the answer. That is, just place instead of x, now x equal to 6.5. We placed here. So, if a particular student studies for 6.5 hours a week, the prediction he's going to get the GPA is 3.47. In this way, we are going to find out the prediction of this regression. Okay. So, this one. So, in this way, we are going to plot the graph. Now, there is another concept called as coefficient of determination, or we can also call it as R square. Okay. It is nothing but a statistical measure in regression model that determines the proportion of variation in dependent variable that can be explained by the independent variable. So why we have to find out this coefficient of determination is it is going to tell how well the data fits the model. Okay. So or it is a measure that provides about the goodness of fitting of a model. Okay. So it in context of regression, we can say that it is a statistical measure how well the regression line approximates the actual data. So this is what the R squared. Okay. So let us see. So this R square is represented by 1 minus sum squared regression by total sum of squares. That is, it is represented by something like this formula 1 minus sigma yi minus yi whole square yi minus y square whole square. Okay, this yi is the predicted value. Okay, this is the actual value. This is actual value. This is predicted value. This y bar is the mean of. Okay. So the sum squared regression, the sum squared regression is the sum of the residual squared. We will find for each and every data set, we are going to find out the errors, that is R, R1, R2, R3. That all we are going to square, that is called as a sum squared regression. And the total sum of the squares is the sum of the distance the data is away from the mean all squared. So that is, we are going to calculate the mean and each and every data point, how much distance it is from a mean. That total square is nothing but this total sum of squares. So as it is a percentage, it will take values between 0 and 1. Always the values ranges between 0 and 1. Some may you get negative values, some you may get positive values. Why? Because in a regression line, below data points are called negative values and above data points are called as positive values. Okay? R squared. So simply we can say R squared as R square or R into R. So what is the difference between this R and R square? It has values between -1 and 1 and has values between 0 and 1. When you calculate R square, it should be the value should be 0 and 1. And it measures the linear relationship between two quantitative variables with respect to direction and strength. Okay. It is a measure of how close each data point fits to the regression line. So when you draw a regression line, when we point these data points, how close each data point is to fit the regression line and tells us how well the regression line predicts the actual values. That's why we are going to use this R square instead of R. Okay. Suppose these are the actual values and these yellow colors are the predicted value. And we have calculated the distance between this actual and predicted and we got some value R square as 0.90. Then we can conclude that R square is close to 1. 0.90 means yes, almost it is equal to 1. It tells that predicted value and actual value are close to each other. That is, our model is the best fit model. Suppose you see, these are the predicted values, these are the actual values. And this indicates R square equal to 0.07. That means it is almost equal to the 0. And there is a lot of difference between actual value and predicted value. So the regression line does not fit the data. As because large amount of difference is there between actual and predicted value. And see, it is fitting. R square equal to 1. We have got R square equal to 1. Then we can say that predicted value of Y for any given value X is correct. Means ours is the best fit model, we can say. There is no errors. So ours is the best fit model. This is how we are going to find out. This R value plays an important role in regression. With the help of, by calculating this R value and whatever the value you will get R, that is describes how well your data is fitting the model. Okay. So this is all about for today's class. Next class, the next session, I'm going to discuss how we are going to find out this 1 minus RSS by TSS with one example we will discuss. Thank you.